Still seeing folks slide in here kind of at the last minute, so bear with us and we'll get started here in another 30 seconds or so. Okay, well, that's a good even number. I'm sure we'll see a couple more folks join, but thanks everybody for taking the time today to join Eric and I to talk about our new feature in Gradle Enterprise Predictive Test Selection. We are very excited to announce this feature. It's been in the works for quite some time and then in a long private beta for a while. And then of course we had a whole push to get all of this type of content out to you to really make sure you have everything that you need on day one to understand what it is that we're doing. So really, really excited to be here with Eric today to talk to you about this. A quick bit of housekeeping. We will be taking questions at the end of the talk in the Q&A panel widget. So you should see that in your panel interface. You should have a little widget that says Q&A. If you type your questions into the chat, there's not a guarantee that they're going to make them into the Q&A panel because it's a bit to kind of watch both sections in there. Also, after the show, we will be spilling over questions into our community Slack channel. I'm posting the invite for that now, and we'll continue to post the invite in the chat so that you can move into there for after the show. Eric and I will both be in there to field any questions that go past the hour. So if you go into that chat invite that I sent, and if you join the Gradle Enterprise room, and I'm sending that out as well, if you join that channel, you'll be able to find us for questions after the show. And of course, anytime you want to reach out to us once you're in the community Slack. Okay, that's a bit about it for the housekeeping. So we have today Eric Wendelin, who is the lead architect on the predictive test selection solution, as well as our principal data scientist who was working on this. So really, this has been his baby. You know, he did the early research on this product. And he's going to tell you a bit about what that story was like, and then successfully productized it, moved it into our product. He took a great idea that was, you know, in the labs and integrated it with what we're showing you today. And I'm Justin Riak. I'm our field CTO. My background is in software development. Now I mostly talk about software development. So with that, let's go ahead and kick things off. So Eric, I think we'll just kind of start simple here. What is predictive test selection?
So predictive test selection is a new Gradle Enterprise extension, which intelligently selects and executes the subset of tests that are most relevant to a code change using a probabilistic machine learning model. And the keyword here is predictive. In that it uses historical code change and test behavior data to predict the subset of tests that are most likely to provide useful feedback for a given change. And so this is not a new concept. Silicon Valley companies have been building their own homegrown test selection systems for years. And these systems usually report between 40 and 70% overall improvement in test runtime with little or no quality risks. And it's no mistake that we called it predictive test selection after Facebook's paper, as our solution is inspired by it. However, there are some innovative ideas in Gradle Enterprise's predictive test selection solution, and I will show them to you now. Justin, can you stop share? Yes, there we go. Sweet. All right, here we go. Yes, so first I'm going to start with showing you this the JUnit project, which has already adopted predictive test selection, the JUnit project. First of all, when predictive test selection is enabled, what it does is it goes back and it compares, it learns from, several months of code and test data, and it will simulate actual test, basically simulate how the model would perform against actual test results. So here you can see the past month or so, predictive test selection would have predicted 100% of test failures and saved about 50% of the time here. Yes, and you can see here, the longest running test tasks. These are Gradle test tasks, but this also works for Maven. So here we have this platform tooling support test takes about 5 minutes on average. And here again, it predicts 100% of the test failures, and it saves about 61% of time on average. And if the system had detected any missed test failures, those would show up here. I'll show you an example of that later, but didn't miss any for now. But you can also see, all of the predictions here, how many tests would have been skipped and how much time would have been saved if you look at the simulator. Okay, so let's see this in action. All right, so here is the Gradle config for the JUnit project, and it has this predictive test selection configuration after applying the Gradle plugin. And predictive test selection will be enabled if this property enable predictive test selection is true. So why don't we just try it out? Test, and we'll enable test selection here. So first off, you can see that this works locally. I didn't have to commit or push anything, just build however I want, and it just works. You can also see that in the logs, predictive test selection is working, and for this, platform tooling support test, it selected 15 of 20 test classes. And then this is hitting the live JUnit Gradle Enterprise server, but the predictions are very fast. It actually only takes about 1 or 2 milliseconds per test class. Yes, so we can take a look at the build scan here. Okay, so it says 337 test classes were not selected in the build scan. We can take a look at that. We can take a look at any one of these. I mean, the test recently passed with the same inputs, so it was not selected. Okay, that makes sense. We didn't make any changes, so let's make a change. All right, so let's see. What I'm going to do is I'm going to take our favorite JUnit XML, and I'm going to change the XML element test suite. We're just going to say test suite, right? And you know what? As a developer, I'm also going to go ahead and modify the one test I know is affected by this to say test suite also. And we'll run predictive test selection again. Let's move this guy over here so you can see the console logging. Okay, so you can see for most of these tasks, it selected, just a couple or a few of the tests. Here again, it selected, maybe 15 or 20 tests here. It really depends on the risk of the change because the system's trying to maintain, near 99.9% of breaking changes caught. Okay, so it looks like we got some test failures here. We'll just take a look at these. Okay, so we had 14 tests failed. Okay, so the legacy XML report generating listener tests was selected because there's a high probability that this test will provide useful signal. And indeed, it did because it failed. So let's take a look at the test and see what's going on here. Okay, so it says that there's an invalid XML document and it's asserting the Jenkins schema. So let's go ahead and open up this file here. Yes, XML report assertions here. And this is actually validating against this Jenkins XSD. So we need to modify the Jenkins XSD here. So let's replace test suite again to test suite. Okay, save that. Run the tests. This takes a little bit longer now that since Zoom is recording. And if I was using test distribution and build caching, this would be quite a bit faster. But in any case, you'll have to believe me that this is actually much faster than normal. Okay, so the test passed here. 206 classes were not selected. Let's go ahead and explore the tests. So let's search for that legacy XML report generating listener test that failed earlier. Okay, so it's, first of all, I forgot to mention this. This selected, you can get a summary of the test selection results here. And this test recently failed, which we can prove. We can go to the test history here. So you can see, indeed, this did fail very recently. We can take a look at the test results here. There's our test result. So what's happening is that Gradle Enterprise actually gets this build scan data and immediately adapts the model. So it knows, like, hey, this test failed, select it. It's very highly likely going to fail again soon, or change status. Anyway, it's going to be very interesting. And we can take a look at the usage here. So this, you can observe how much test selection has been used. So here we have 648 test tasks, which ran this, saving about 5 hours of time for the JUnit developers. Serial time, by the way. You can take a look at the details for this longest running test task. And one thing that's interesting and new here is that we report the mean duration is actually 68% faster with test selection enabled. And you can take a look at, here's our builds that we just ran at 11 a.m. And you can also take a look at, builds that didn't run test selection, how long they took, for example, and also unavailable if there had been if test selection was attempted but couldn't be used because of a network timeout or because for other reasons that client's not authorized, you would see those there. Okay, so that is an overview of the product. Yeah, that's what I have to show you so far.
So first of all, that's really cool, but I can't help but notice that you're skipping a lot of tests. Is that safe? How does this all fit together to make sure that we're not skipping important tests?
Yeah, it could be scary, but first off, the Gradle Enterprise model is trained to catch, roughly 99.7% of faulty changes and over 97% of individual test failures for a wide variety of projects and test types. And based on our experience operating this for several months and lots of dogfooding with beta customers, we found those correctness guarantees are sufficient for many types of tests and builds. Facebook's strategy is very similar, and they also convey the same sentiment in their paper on predictive test selection. Secondly, when you're using test selection, you still ensure that changes are comprehensively tested before releasing your software using test runs that do not use test selection. So, but you use it, if you disable test selection later in the change cycle. So for example, as part of a post-merge build or a nightly build or a ready for release build, you should run all the tests to ensure that no regression slipped, but the chances are very low. And speaking of post-merge and nightly builds, I've observed that many teams, if not most teams that I've met, do not run all tests before they merge changes to a mainline branch. And if that's the case for you, you're already basically doing a manual form of test selection. Finally, I get that even with the backing of statistics and machine learning, skipping tests can be a scary prospect, which is why we built elements of transparency and control in Gradle Enterprise. So in the test selection simulator, it compares the actual test results to what the model would have predicted. So you can see what it would have done before you even enable the thing. You can configure exactly which test runs enable test selection and control individual tests which are selectable or not, or you can control which ones must always be run. And you can also inspect the selection trends and for a group of tests or a single test, get those logical explanations of why test selection selected or did not select a test in build scans. So those things combined really are intended to kind of establish a baseline of trust, because that's probably the number one thing that will hinder adoption, is that folks can trust this. So put a lot of transparency and control into the product.
That makes sense. And now I've heard of something similar to that uses code coverage data to manage test selection. Is that what we're talking about here?
No. So there are companies and services out there that do test impact analysis, and they claim like 10 times faster tests just by using static or dynamic analysis of code, or they use something like reverse code coverage data. Predictive test selection is absolutely not that, and here's why. Anytime you use dynamic dispatch, like Java reflection, the precision of the analysis is compromised. Anytime you transition between languages, so if you have like code in Java and your tests in Groovy or whatever, you have a multi-language code base, which is very common in large teams, that the analysis is either incomplete or faulty. It's very difficult for that to scale. And if you do something like dynamic analysis, it still is like, it still falls short, because it's fundamentally impossible to know the control flow of a test execution before the test is run. And the fundamental problem with these kinds of approaches is that they break down or don't scale for the very kinds of tests that you want to save time on. So for example, integration tests, browser tests, end-to-end tests, those are the ones that are painful and slow. And you know, the like code coverage and dynamic analysis just doesn't quite cut it in practice. And Facebook also found the same thing.
Okay, and we've had a couple of questions that come in that have already come in kind of related to this, asking what type of tests these are most beneficial for, but we're actually going to get to that a little bit later in the talk. So just bear with us on those, but some really good questions coming in that will coming in the Q&A panel, and we'll address those. So, okay, it's not doing dynamic static analysis, not doing code coverage analysis. It is using machine learning. How does it work? Can you kind of break it down for us?
Yes. So as I said earlier, when you first turn on predictive test selection, it automatically learns from code changes and test outcomes from your build scan data. And while it's learning, that test selection simulator I showed you compares the actual test results to the test results the model would have selected. And so you can see how well learning is going. And then when you're ready, you can turn on test selection for real. And what happens when you do that is that your build submits an input snapshot and a test set to Gradle Enterprise, hosted, so doesn't leave your network. And that then Gradle Enterprise, invokes the machine learning model, which then predicts the relevant subset of tests, which are subsequently executed by your build. And after every build, the new code and test data from build scans is processed immediately by Gradle Enterprise to adapt to new changes and test failures. So finally, that the test outcome and test selection usage is visible in the build scans and the test dashboard, and in predictive test selection dashboard. That's how it works high level.
How's the machine learning model trained?
So we start with a base XGBoost model, which is trained on over 10 million test executions from over a year's worth of partner data from dozens of different projects, and not just any projects. Like, our data partners are software teams whose products you use on a daily basis. Fun fact though, I did not use Gradle data for training because I found it skewed the model too far toward build changes, because test selection also is aware of environmental changes such as the JVM that's invoking tests, the operating system, those kinds of things that are sort of ephemeral, like system properties. Those also kind of influence test selection predictions.
And you mentioned XGBoost. Right. Why XGBoost and not like a TensorFlow or like a deep learning model?
That's a good question. So first, I want to clarify that the machine learning model is actually an ensemble model. However, XGBoost serves a key part. And I tried to avoid using machine learning initially because machine learning increases the complexity of the solution. So I first tried some statistical models and found that their predictive power, just wasn't sufficient to base a product on. And I also tried, simpler scikit-learn models and found that while outperformed statistical models, we knew we could do better. And in the end, I took inspiration from Facebook's published model and found XGBoost to be the most effective at predicting relevant tests compared to statistical and other types of models, but also more practical than deep learning models. And that is because XGBoost models are just typically less complex and more interpretable in general, and that interpretability is really important. XGBoost is very fast, so it only takes a millisecond per prediction, which is really important if you're trying to do something in real time. We also wanted to avoid the need for specialized hardware to keep this speed, like GPUs, because this is a hosted product. So we don't want our customers to have like specialized servers and stuff like that. And even though we had a lot of data, the lower data requirements of XGBoost compared to TensorFlow and PyTorch, like deep learning models, are preferable when the system is embedded in custom hosted sites.
That makes a lot of sense. Yeah, I mean, I guess we wouldn't want to have to all of a sudden start requiring people to use a GPU alongside Gradle Enterprise. And I guess if you could get the job done using a less complicated model, then that makes a lot of sense. So then, with the boosted model, how does it determine which tests are going to be relevant?
So I carefully crafted the feature variables to model real life development scenarios and chose an interpretable model design to enable predictive test selection to explain its predictions, which you saw in the build scans earlier. And the model takes many variables into account when making a decision. So for example, which code changes affect which tests in different modules, how new the test is, how flaky the test is, how the test reacts to different types of changes, the nature of recent code changes, and so on. The key goal is to maximize the value per unit of testing time. So the model will prefer faster tests that when it can gain the same amount of information as slower tests. Yes.
So the demo that you were showing us earlier looked like that was on the against the JUnit project, which is great. That's one project. But what about scaling this to kind of big, complicated, real world projects that we might see in the enterprise? How do you know that you're really able to trust it on something that might be not as straightforward?
Yeah, so that's the reason we have the simulator. And so I'll just show you some simulation results that we have from some of our other projects who've kind of adopted this already. So this is Micronaut, like a popular microservice framework. So for the last month, or so, predicted 99.9% of faulty changes, at least, and 99% of test failures, and save about half of the time. And so you can take a look at these results and see what the model is doing. So for example, this test, it looks like it missed some test failures here. We can take a look at them and see what happened or what's going on. All right, so I'm not a Micronaut developer, but when you look at these, one of the things I see is like, okay, well, this single test class had a test method that was flaky and a test method that failed. This is kind of surprising. Usually, things like this might indicate that there's some kind of resource leak. We're not sure. Again, I'm not a Micronaut developer, so I can't tell you for sure. But users, like, you look at the simulator, look at the results, and see where did it make a mistake. If it made a mistake, and then you decide. You decide for yourself. Yes. So and then you could also take a look at the Spring data. Where does it go? Spring data. Okay. So here's Spring. Also, they're on an older version of Gradle Enterprise. But last week, just pulled it to last week, 100% of test failures predicted, saving about 36% of time. You can just go to these sites, go to ge.spring.io right now and check it out. Again, this is not on the latest version, so doesn't have the pretty green and orange kind of stuff. So maybe these results will be slightly better when they upgrade. Yeah. So, I mean, and if you're not convinced by that, then, check it out for yourself. You can use the simulator on your own projects and see, and there's very little risk to doing so.
So what if the simulator shows me that some tests are going to benefit from this, maybe, but not the full set of tests? Do you have the granularity to go in and say, I don't want predictive applied to this set of tests, but I do want it applied to this other set of tests?
Yeah. So as I mentioned earlier, you can configure individual tests which are eligible for predictive test selection. And you might do this. So you can do something like in the predictive test selection configuration, we have this must run configuration. You can say include classes that match a certain pattern. So you could say something like ** important test, right? You can also include classes which are annotated with a given annotation. So you can say include annotation classes. And just com.sample performance test. So anything that's already annotated performance test, you're like, if you already see, like either you really want those to always be run, or you think that there's some risk that predictive test selection is not going to do well, you can just add those tests so that that's always run when they're always selected.
Okay, yeah, so that clears that one up. So you really do have pretty granular control. So what kind of tests is this going to work for? You mentioned briefly before that, some tests really see a lot of benefit from this. One of the questions that was asked earlier, I'm going to go ahead and repeat this question so that we have the context in this part of the explanation. But Brian is asking, what kind of results do you see in practice comparing unit integration and system level tests? It seems like this would be a big win for large system test suites since they take generally longer to run.
Yeah, so first of all, predictive test selection works for most types of JVM-based tests, which are compatible with the JUnit platform. And so obviously unit tests, also integration tests, browser tests, and end-to-end tests that use JUnit platform compatible test runners are all compatible. Also any JVM language that's class-based, Java, Groovy, Scala, Kotlin, Clojure, and so on. Those can all be used. For Android, it works for Roboelectric and normal unit tests, but it does not yet work for device tests or instrumentation tests. And you can find a full list on the docs that we'll show you here in a bit. And you're right that really end-to-end tests and system level tests are the target for this kind of product, which is why I trained the model to specialize in being good at predicting those system level and integration tests. The tests that I was actually running those were the integration tests. The platform tests for JUnit, those were the integration tests. I mean, they take like a minute and a half. Doesn't feel like an integration test, but that was what they are. So yeah, actually, the point is to specialize and make sure that those expensive tests justify their existence, and that they only run if they really going to provide some value. Because otherwise, you could run like 1,000 fast tests and maybe get the same value. Who knows, right? Well, the machine learning model kind of knows. That's the point.
Machine learning model knows now. Yeah, that's great. We know who knows. So. And could you repeat what you said before? We had another question about specifically, does this work with Android tests and Android unit tests? I think you mentioned the only constraints there were instrumentation and device tests. Is that right?
So it doesn't work for connected tests, and it doesn't work for like Test Lab, Amazon Device Farm, those kinds of things. We're aware that this is a big opportunity. So.
And then we had one more question come in actually at the very beginning. Are there plans to look at extending this to support like co-test and some of the other Kotlin test suites?
I would say, yeah, submit a request if it's possible, then we'll take a serious look at it. Usually, what's missing there is some kind of JUnit platform compatible engine. I think for the specifically co-test, there's a question of we might have to enhance the JUnit platform engine, or there might not be a JUnit engine for that yet. I'm not sure. I'll have to ask Mark. Mark's on the team, so
there you go.
We'll find out.
So let's talk a little bit about combining this technology with some of the other Gradle Enterprise technologies that we already have for acceleration. Is this something that, would you say sort of complements these things? How does that track with you?
Yeah, so predictive test selection is complementary to build caching. Partial test results are not stored in the build cache. So if you have, if you run predictive test selection on a branch build, those tests are not cached. And then on the, your mainline build, you'll resolve that from cache. And, if you would have missed any test failures, right? But if, you have subsequent runs of predictive test selection, it knows whether or not a test has passed for the same input snapshot, if you will, and it's much, much less likely to select it. So if you run again, you might get a slightly different set of tests, and often very few tests. Predictive test selection also works with test distribution. So tests selected for execution then get distributed. Is how that works. And so it's basically, if you combine those two with slow test analytics, where you can identify and speed up your slowest tests, you basically have an unbeatable performance combination. And you can accelerate your test runs by 10 or 100 times, depending on your needs.
Wow. Yeah. I mean, I think it kind of went without saying, but I mean, with the goal of our product, and I think with the mindset of DPE to really be the wrong question is the build fast enough, right? The question is the build as fast as it can possibly be given all applied technologies, because that's what our developers deserve. That's the investment that we should make. So what we're saying here then is we've got this great framework where caching can help you avoid some work, predictive can help you avoid even more work, and then with whatever work still needs to be completed, we can distribute that work in parallel. So we're really just hammering this thing from 3 different angles. And of course, we're keeping that performance continuous over time by making sure that we're keeping down the amount of flaky tests, unnecessary failures, and that sort of thing that developers are encountering.
Yeah, that's right.
So what if I wanted to get started with all this?
Well, the short answer is to contact us through the website, or to reach out to your Gradle Enterprise account manager if you're already a customer. Obviously, we love open source at Gradle, and one of the ways we give back is to sponsor Gradle Enterprise for open source projects. To set up Gradle Enterprise, it runs on Kubernetes. You install it with Helm. It's pretty standard. And once you're set up, you don't need any additional infrastructure other than the Gradle Enterprise server. So you don't need to worry about your sensitive project data. It never leaves your network. Then, once Gradle Enterprise is set up, you can enable predictive test selection and see the simulator working for yourself. And you can see it before you try it out for real. And you can see here here's the link to the docs. If you go to docs.gradle.com, this will tell you many of the things I already told you about how it works with other technologies, when it should be used, the compatibility between with different frameworks. And, so a bunch of frequently asked questions are also there, how you use it with Gradle and Maven and so on. But of course, you can just reach out to us on Slack or wherever.
Excellent. Yeah, and we'll provide some more resources here as we kind of conclude to our Learning Center, as well as our ebook, which has now been updated to include a lot of this newer technology that we've put in place. Well, that's great. I mean, obviously, this is really fascinating technology, and you've done a lot to, I think, allay concerns over, the obvious, fear of change in the way that we sort of approach our testing. But I think there's no question when you look at some of these results that we see from Micronaut and from Spring and from our own projects that this is going to be, sort of another revolutionary technology that we're able to put into our toolkit here to make sure that developers are experiencing as little friction as possible. Well, great. So we got a lot of questions that have queued up here. So I think we can go ahead and go into those. Before we do, I am going to post once more the link to our community Slack. This will go out to everyone inside of the Zoom chat. You can use this to join up in the community Slack, and you can join the Gradle Enterprise channel. And in that channel, you'll be able to, after this webinar, if you'd like to continue the discussion, we'll be in there fielding questions, and we're sort of in there perpetually. So great. Let's start at a question then that actually came up around going back and revisiting the build cache. Can you repeat what you said about the relationship specifically between stuff that gets cached and stuff that gets selected? How maybe the more general question, how is the build cache and predictive test selection related? How are they related?
They use the same technology to detect, basically to inspect the inputs to your tests. So you have, it basically can look at your, essentially all of your file inputs, all of the class loaders and everything that participates in the test execution. And when it does that, it knows, and given the test history, it has the test history for each of these input snapshots, if you will. So, for example, if you run predictive test selection, multiple times in sequence, what you'll see in the build scan is that many tests will not be selected because they already passed for the same input snapshot. But those test results are not cached in the build cache. So others who are running those same tests, like Gradle Enterprise, knows that those tests have already passed for that input snapshot, but you won't resolve partial test results from the build cache and then use that to continue your validation pipeline. Does that answer your question?
I think that does. Yeah, I mean, it was really the question was about the mechanism between the two, and I think that does clear it up. Of course, the participant asked that question. If you want to post some Q&A, let us know. If you still need some more clarity, we've got some time. Bharat is asking, how does this work if you have multiple build flavors and the code change is in a core library or module that's used, but it might not be affecting all build flavors?
Yeah, so my understanding is that different build flavors in Android have different test tasks. And if that is correct, essentially what predictive test selection will do is for each of those test tasks, it maintains relationships and history for which tests are sensitive to which types of changes in your core or library module. So that means that its predictions for one flavor will differ from what's selected for a different flavor if you're running free or paid versions of the app. Like if you make a change to a core library, it might select a few tests from your free version and many tests from your paid version. Whatever it thinks will basically maintain, very, very, very high confidence that it's not going to miss a regression. Does that answer your question?
I think that answers it for that makes sense to me, but of course our participants can write in again if they need to double down more on that. Really good question here. Michael is wanting to know, does Gradle Enterprise provide a pre-trained model, or does it have to be trained on particular projects?
The answer is both. So first of all, the pre-trained model is shipped with Gradle Enterprise. And then Gradle Enterprise takes some weeks to learn about your projects before it will make predictions. So what you'll see is that in the simulator, it actually will say, oh, I have insufficient data to make a prediction. If you see this, it's because it doesn't have enough test executions to be confident enough to make selections. So it's actually doing both. It's learning, it knows some things, but then it needs to learn about your projects. And so if you have a new project, it's going to select all the tests for a while. But I mean, it also will learn from historical build scans before making those predictions.
What is what's meant by like insufficient data? How do we kind of quantify that?
So specifically, any test, task, or Maven goal that has less than 2 weeks worth of data or 50 executions, outright the model doesn't even see it because the system just doesn't have enough information to make predictions. Similarly for like new tests, if you introduce a new test, the model might say, oh, I'm selecting this test because I don't have enough data. So it needs at least a couple weeks of time and 50 executions for each test and test task in order to make those selections. That's what that means.
Okay, that makes sense.
More time is better though. If you have at least a couple of months of data, that will make your model better. So, I mean, keep looking at the simulator and then see it improve over time. It gets more confident over time.
Oh, sure. That's a good point. You can use that mechanism then to decide, like you said before, on the simulator and when to actually flip the switch and tell it to start working at the client level. Okay, that makes a lot of sense. Can you expand? This is one of the I think one of the more impressive features of predictive test selection is its explainability. Andres is asking, can you expand a bit on logical prediction explanation? What's that explanation based on? And is there like a mapping from attributes to logical explanation?
So I'm not ready to share deep details of how this works yet, but what I'll say is that what went into that was careful consideration of the feature variables and then a well-tuned heuristic of basically the model tells us which features were most important for a prediction. We use that to infer essentially, there is like a static set of reasons. There's a long list of reasons that it can map to. But any more detail, I'll have to wait for approval to share that.
Makes sense. Yeah, I guess some of this stuff is still kind of our IP as well. One of these questions came up in the main chat. This is a really interesting question. Interested in your take on this one. If we need to track code coverage, that it looks like with predictive test selection, that's code coverage would sort of fluctuate. Do we have to give up tracking code coverage, or do we have to infer that coverage in a different way?
I would say you would need to track the code coverage at your, like mainline branch level, wherever you are running all the tests, then that's where you'll want to measure the coverage. If you're doing something like, well, we want to know the code coverage for our branch, and we want to use test selection, you're gonna have to choose. You can't have both. We don't know. It doesn't know what code paths would have actually been executed. It's fundamentally impossible. So sorry, there's no magic bullet there. You either get time savings or comprehensiveness. That's the trade-off we're making here. We're taking smart risks.
Gotcha. And along the lines of smart risks, and you did mention this before, but the question was asked, and this is an important thing to understand about the way that predictive works. Does prediction test selection do any reordering on test execution?
It does, but it is not deterministic. And all of these tests are partitioned across all of your different test executors, and so it doesn't some folks have asked, like, can we just turn on ordering and use fail fast? I mean, we could, but statistically, only like less than 5% of test runs fail. And sure, you catch it in the first few tests. The reality is that that's just not enough benefit that we've found for people to pay for it. I mean, if you're willing to pay for it, for just reordering tests, like, fine. Please contact us, and if enough of you contact us, then we'll split a product out that just does. I mean, if you really want, what you could do is tell test selection, like, include classes star, right, and then it'll select all the tests, and then they'll be reordered, but then they'll be partitioned in a way that they're partitioned in a way that allows for like maximum throughput. So you're not getting like the most likely to fail, then the second most likely to fail, and so forth. It won't work with all the parallelism that's going on,
That's pretty clear. Another one that came up here, which and this is a little bit ambiguous because I know we've been putting this one up alongside test distribution, but the question was asked: does predictive test selection? Ryan wants to know: does predictive test selection actually require running test distribution as well, or can you just run predictive test selection?
It does not require test distribution, but it does currently use the test distribution Gradle plugin, but it's all one plugin. So no, you do not.
Okay, no, that's good to know. Yeah, I mean, if you look in the docs, it tells about using the distribution plugin, but you just use the same plugin. We do that for convenience, but yeah, okay, no, that's good. That clears it up. Time for a couple of more questions, and then I think we'll wrap things up. And of course, we'll continue the discussion as long as everybody wants in the Gradle community Slack. How does the failure mode? This is a good one too. How does the failure mode of the test affect prediction? In other words, what Hari wants to know: how are things like environmental errors, non-deterministic failures, and things like that versus functional errors, and I guess assertion errors and things like that that are actually due to a code change? How do either one of those different types of failure scenarios impact the model?
A very good question. So environmental and flakiness errors that the system can detect are marked as flaky with regard to the machine learning model. And what the model does to ensure that very, very few regressions are missed is it selects all of the flaky tests because it doesn't know. They're inherently unpredictable. So it will select them. If a test is recently flaky, it will always be selected for right now. So when it can make that classification, in other times you'll see in the simulator where infrastructure failures are marked as incorrect predictions, possibly incorrect predictions, because the system did not detect this. This is actually the flaw is outside of the code under test. It's in the test environment. And in which case, you essentially have to sort of exclude that from the simulation results and say, well, it said I made a mistake because it's a conservative estimate, but it actually didn't miss a test failure. Like that test failure did not actually give information to the developer. That's the thing we're going for. Like, is it relevant to the code changes? And the answer is no. So wherever possible, sort of like excluded, marked as flaky, always selected, so on.
That does kind of clear it up. I guess we do have time for maybe two more, because David has posted another very interesting question here. This seems like maybe kind of a niche scenario, but let's see. Would the prediction work even when end-to-end tests are in a separate repo and tests start the application in its own JVM? Could imagine that would be hard to detect the actual changes done to an application.
Yes, it knows. It knows as long as the Gradle as the Gradle build or your Maven build can detect the inputs coming in to those end-to-end tests. So the inputs are probably, jars, some kind of artifacts are coming in as test inputs, as long as those are declared as inputs to your test in your standard Gradle and Maven configuration, then Predictive Test Selection knows about them and will take appropriate action.
Perfect. Makes sense. Okay. Well, I think that's pretty much it for the questions. I am going to, we have one more last one here. Can the test selection work with test distribution? Absolutely. We actually did kind of cover that earlier that the two of these are very complementary. They don't have to be used together. There's no requirement, but if you use them together, you can expect to see even better results because you have one mechanism helping you avoid work in one area and another mechanism helping you to distribute work that actually can't be avoided. So that's, really, we do want to drive home that using these three technologies for acceleration in tandem are where you get these massive results. I mean, Eric, talking about results up into the, 60, 70, 80, 100x in some cases when we're combining all of these things. So it can be very, very transformative when we combine all of these acceleration technologies. Great. So we just have a couple of things here to kind of wrap up with just some resources for you to check out. If this is fascinating and if you'd like to kind of learn more, we have put together our full solutions page at this point. So you can come into this section. We've got a header video that you can see up here at the top that kind of, it's about a 5-minute video that will explain kind of a lot of what we have put together today, just kind of in more of a bite-sized format, as well as some descriptions of the individual features. And so, yeah, I would encourage you to come check out the site. It's new. It just launched along with the product, and there's a lot of data in here that can tell you more about it. And then, of course, we always recommend checking out the manual, checking out the DPE ebook. This is really the comprehensive guide to establishing DPE principles and strength within your organization, starting from, just talking about the pillars of developer productivity engineering. Why is now the right time for your business to be investing in developer productivity? I've actually been on site at a couple of conferences today and last week, coming back to real life conferences again. And everyone in the platform and DevOps space is talking about productivity right now. I mean, that's kind of the consciousness of the DevOps and platform world, is really thinking about how we can vertically scale our organizations by improving individual developer productivity, which is, of course, what Gradle Enterprise is all about. So thank you so much for joining us today. Thank you, Eric, for all of those details and for bringing this product to us. And again, if there's anything else that didn't get answered today, or if you'd like to continue the conversation, please reach out on our community Slack. And if you'd like to get started with the product, you can reach right out to us through the website and get started with the demo trial, any of those things.
One last thing, I'm hiring a couple of data scientists. If you are interested in working on this, because we have a couple more, upcoming products that are really, really exciting, go to gradle.com/careers and hit me up.
Awesome. Thanks. Take care, all. Talk to you next time.
Cheers. Bye.